Hello, welcome to Sean Builds a Lisp. My name is Sean and I am building a Lisp. Last few sessions, what I've been trying to do is kind of figure out how I want my AST to work for my Lisp, and kind of gone down several paths. And in the last session, I realized that the most recent path, I think, just is not going to work at all. And I think we're going to end up coming full circle and pretty much going back to what we started with a few modifications that we've learned along the way. I'm pretty excited. I think it's going to work out pretty well. So what I'm going to do here is I'm actually going to grab my master branch. And it's a good thing we've been working in branches, because the master is almost exactly what I want it to look like. So it's been a little bit, so I'm gonna poke around and remind myself of where we were. So if we look at our readers, so for example, read list. So right now, this reader is essentially filling up an array and then returning that array. And then in our main read function, we take and we call syntax on that array. And syntax is simply a function that looks at the type of the value and returns a Babel AST that's appropriate for it. And we added this weird symbol literal additional AST node, which I don't think I want to do anymore. So this was mainly because I was trying to make quote be a macro that would be expanded by the macro expander. And so in order to differentiate like an identifier versus a symbol, a quoted identifier, we needed to have this extra step where we parsed a symbol literal, and then a quote would essentially strip that off so that you would end up with your symbol literal back, and a symbol literal would actually be compiled to an identifier. But I don't think that's what we want anymore. In fact, I think I just want the readers to return Babel AST nodes directly. What this will allow us to do is essentially make it really easy to add extra literal syntax. So I'll just grab a comment here so that I can kind of demonstrate what I'm talking about. So I think our read list function that we were just looking at really needs to return a Babel call expression. So if you were to do something like this, this would be type call expression, callee identifier. Yeah, I'm just going to use kind of the types here. So this will be a call expression with an identifier foo, and then arguments of bar. And then, so by having our list reader return call expression directly, what we can then do is make this syntax return an array expression that's pretty similar. I'm just going to copy paste to that, speed things up, and clean it up. There we go. And so now, with this kind of mechanism, we can start doing interesting things, like if you define a function, one way to do it would be like this. Oops. Return foo bar. And so basically this would be a function that returns the call to foo and bar. But then you could also kind of write it closure style by default, and we can make our function macro essentially not care. And so these two things would ultimately compile down to the same thing, because the arguments is really just a sequence of expressions, and so it'd be nice if it didn't matter what kind of sequence it actually was. Another cool thing that we could probably do is maybe cool, maybe not, is you could actually make it look like this, and I think that the expander just wouldn't care, because this kind of syntax would also ultimately compile or be compiled as an object expression, and which still just is a sequence. And so anyway, the reason I tried to go away from this in the first place is that I wanted it to be fairly straightforward to work with these syntax objects by index, so like by number, so that this function, like if you have, let's just take this example. So if you were to do like foo bar 0, oops, that would just give you foo. And so this actually parses as an object, so 0 doesn't make any sense. So I started going the route of having everything actually be expressed by arrays, and the problem there becomes when we have a quote, we just can't attach any metadata like source location. But if these are just objects, we can attach all the metadata we want, and it won't interfere with other things. So how do we get both of these worlds? So I think what I'm going to do is essentially build a library of helper functions for dealing with Babel AST nodes, such that, like, for example, you could call first on foo bar, and then this would give you foo, or maybe nth foo bar and 1. So this would give you bar. And now these are the actual identifiers. And then we can go ahead and make a slice foo bar, maybe 1, and this would give you bar. And I think that this is kind of nice because it actually feels very Lispy, and it kind of it both feels very Lispy. It allows us to have syntax objects as our kind of common denominator, and they're fairly transparent, so you can deal with them as if they're symbolic. So I guess from my reading, one of the main things that kind of separates a scheme from like a common Lisp is that common Lisp is like symbolic processing, whereas scheme is syntactic processing, if you will. So scheme has syntax objects, common Lisp has symbols, and there's pros and cons for both. We have to have syntax objects, as we've discovered, so but I still want it to feel fairly Lispy, and so I think that this is going to be fine. I guess I should note that this is actually going to, well, I guess we can see. Like with something like slice, where you're returning another collection, the question is, if you call slice on a call expression, should you get a call expression back, or should you just get kind of like the raw datum? I think let's defer that decision and just start building. I think that might come fairly obviously, and I think that this should work. So what we need to do is this whole syntax thing has to pretty much go away. So we've got to go modify our reader functions so that they return Babel nodes. And yeah, I think that this is fine. So basically we can start importing some Babel constructors here. So let's grab call expression. So I'm going to just start with list, and we'll see where this takes us. Oops, not generator, we want types. Okay, and now if you remember, we're deferring back to the main read function, so all of our readers are going to return AST nodes. So think all we need to do here is, actually, let's just start right away. All right, so let's grab our collie. So we will essentially just call this right away. And then we will grab our args, and that's just going to be an array. And so as we're going through here, we'll push what we read onto our args, and then at the end we can call t.callExpression with collie and args. And now our list reader will, oops, not t dot, we destructured that. Okay, so now our list reader will simply return a call expression. So now we've got to go grab our string reader, read string. So this guy is fairly a bit more straightforward. So this, we'll just call string literal with our string content. Ooh, you know what? Actually, we probably still need our syntax because we need to assign our source locations. So all right, well, we can get there. Okay, let's just keep going. All right, so we're just going to call string literal with our string content, and this will also need to be beefed up. We'll want to put like raw string and stuff in there too. But just for the sake of progress, let's keep going. Okay, so read number, we're going to, instead of returning just a number, we're going to return a numeric literal with our number. All right, and of course we'll need to grab that. I think I forgot to require that in read string, so we'll go back. And I'm just going to copy that so that I can paste it in here. And this should be string literal instead. Oops. Okay, so the last one is ReadSymbol. And so what we want this guy to do is to be an identifier. And we'll need to grab that from Babel as well. Oops, Babel types, okay. Now in read, we're just gonna get rid of this syntax. Okay, so now we don't have, actually we'll just do object.assign, and we want this to just be the location. So what do we got here? We want this to trivia, and this will have a start, which is, you know what I'm realizing? I'm realizing that I had made a location function just to make things easy, and so I'm gonna do that. I'm just gonna, we're gonna end up typing this a heck of a lot. Okay. All right, so module dot exports equals function location. Okay. Call this lock. Yeah, I'm just gonna call this lock. Kind of match where it's gonna go. All right. So let's do start and end trivia at the end, and so Okay, so I'm gonna actually just attach some other helper functions to this. Okay, position, line, column. And this will just be an object with line and column. I think I might want to attach some more metadata, but that's fine. So basically, is this going to be easier? Let's see. Okay, so we've got, oh, you know what else we did? We modified our reader, or our input stream, so that it would track positions. Okay, so what we're gonna do is just fix that too. All right, so all right, let's see. So we can just do that and return char. And then what we want to do is also attach a line and column. So this dot line will start at 1, and this dot column will start at 0. Okay, so if char is equal to new line, then this dot line plus plus and this dot column gets reset to 0. Else this dot column plus plus. Okay, so now, excuse me. Okay, so what we can do here is all right, so we read stream, and the very first thing is we want to pull out our trivia start. All right, so I'm gonna just make this a little bit easier. We'll do get position, and so we can just return line is this dot line and column is this dot column. Okay, so now we can just do stream dot position. All right, and then form start equals stream.position, and then once we're, we'll want, all right, form equals reader. So basically I'm just pulling this reader function out so that I can grab the position. Actually, we don't need to do that. We can just do this in one. Okay, so this will be form start, and then we've got reader.position, and then we've got trivia start. And now we have our annotated AST. Okay, so this object.assign might slow things down a little bit, but we'll get there. Okay, so we have a bunch of tests, and we haven't run them in a really long time because we've been experimenting, but they should be pretty close to passing at this point. Actually, no, they are not. They're not even going to finish. Okay, so let's just jump into, what do we want to do here? Let's look at our, let's just look at our reader. This isn't even gonna, yep, okay, there we go. It looks like we infinite looped there, which is a bummer. Okay, so we'll just I'm just going to grab this location function so that we can just kind of quickly fix our tests here. All right, so what are we doing? We're reading a string foo, and so this should be, let's also grab a string literal from Babel. String literal foo, and we want location, and what do we got here? So position is going to be, so start is 1 0. Whoa. And oops, end will be 0. All right, we're just gonna have to count 0 1 2 3 4 5 1 5. Whoops. And our trivia will just be the same as our start. Okie doke. So what I'm gonna do here is I am just going to comment out the rest of these, and I just want to run this test and watch it work. Comment and comment and comment, and we'll just kind of slowly make this test file recompile. All right, I think crazy mouse aside, we can do that. All right, so now we can do npm run. Sorry, actually, that's probably, oh, is that in my other? Okay, it's there. All right, so what I was looking for is I remembered making this test script that only runs a certain file, or lets you specify the files to run for tests, and I just couldn't remember what branch I had put that in. All right, so we want to do, let's do ** read.spec.js. Okay, we have a typo. Is that, where is that typo? There it is. Okay, let's try that one more time. Still no good. Okay, what do we get? Actual is undefined. Okay, well, okay, so let's test current, and where's this? This is in read. We want to look at read. So that's another typo, and this should be call to. No, it's not. Okay, it's a getter. All right. Shall we just try it again? Maybe we fixed it. Oh, stream deposition. not reader. Okay. That's where TypeScript would have come in handy. Okay, so it looks like this is a good strategy. So let's go ahead and get this guy going. Okay, so this is going to parse into an identifier. You know, there are type definitions. I feel like VS Code could help me out a little bit here. All right, so this is going to be object.assign, and we'll create our identifier, and it is foo, and let's see here. So we're gonna do lock.position 1 0. We have a syntax error. Where's that? Just need some extra. Okay, just wanted to get this a little cleaner. Okay, so let's end. Oh, there's some white space at the front, so that should read into the trivia. Okay, so then end will be, we've got 0, 1, 2, 3, 4. Line 1, column 4. And our trivia will be at 1, 0. Okay, let's continue. Let's just make sure that this all runs. No kidding. Okay, so basically it looks like we didn't read our trivia. Why not? All right, I'm just gonna compare. Did I delete something I wasn't supposed to? Yep, okay. And we deleted this line. There we go. Okay, let's try this again. Look at that, tests for the win. Okay, so that's great. All right, so now we've got about a bajillion number tests to fix up. Okay, so alrighty, so what do we want to do here? I'm gonna just make a little helper function real fast for this because I noticed that all these tests are the same, so it's pretty much we're gonna object assign our number, and that's pretty much it. So we'll save some boilerplate. All right, so heck, let's call it syntax, and we don't even have to change any code. Okay, so what are we gonna do? We're gonna assign. All right, I'm gonna jump up here. We're gonna need a numeric literal for this. And while we're at it, let's just also put call expression in here because that's coming up. All right, so this, where's the syntax? N. All right, so we're gonna object assign. Numeric literal. Actually, I'm gonna do n and length is equal to 1. All right, and then location. All right, so start is going to be 0. So position 1 0. And then end will be location 1 length. And trivia will be also 1 0. So basically that means that pretty much most of these tests should just run. So what else? This guy will instead be syntax with length 2, and everything else should be fine. So let's do it. Oh, look at that. We don't have any list tests. That didn't work at all. Look at that. Okay. Oops, I think that was just a typo. I think I needed lock position here. I don't know, that this isn't really all that easier to type than, well, maybe it is, than nesting the objects, not sure. Hey, we've got our tests up and running again. That's so exciting. All right, so we have a bunch of other reader tests. So we should probably just go update all those too, huh? All right, what do we have here? Okay, so this is just going to be some painful boilerplate. You know what? Screw it. We can fix these tests later. What I'd like to do is jump over to our expander. All right, so let's remind ourselves what the heck we're doing here. So I think a lot of this can stay pretty much the same. Okay, so the one thing that's different is we are now parsing this as a call expression. So this should be, we're going to expand the callee, and I'm not going to get to this. So what we were doing before is for quote, we were simply stopping expanding. So, and for syntax quote, we essentially lifted everything up. So I think what I'm gonna do instead is, so instead of, I think that like, and the main reason for that was we had this weird thing where we were like, essentially to get an array expression, we were quoting an S expression, which is just a little too complicated. So I think what I'm gonna actually do here is just change this to quote, this to quasi quote, and then so we'll delete this, and then what we need to do in quasi quote is look for unquote instead of syntax unquote. And then this would just be unquote. Okay, so now we have a bunch of problems here because we're still looking for symbol, weird symbol literal things here. All right, so delete that, delete that. Okay, so now these are no longer elements, but these are the arguments on the function. or sorry, the call expression. Okay, so we are resolving, oh my gosh, look at this. We built hygienic macros already. So this is also kind of strange. We're checking first twice. I think that was just kind of like a weird thing we were doing. All right, so we expand syntax.callee. If it's an identifier, we will do some special stuff for quote and quasi-quote. Otherwise, we'll look up the identifier in our macro list. And if we find something that is a function, we'll call expand by calling that function. Okay. And then we have syntax to datum here. What are we doing? Okay, so this is checking call expression, and then I think what we should do here is just see if it's an identifier. So if the callee is an identifier, and okay, this is a little weird. I'm just gonna go ahead and okay, so I think that the syntax quote is essentially correct still. So what I'm going to do is we can call this expand quote. I think I'm going to all right, it'll just be a little easier to deal with here. I think I'm gonna get rid of quasi-quote altogether, and let's just keep things simple. Okay, and then call expression is a bit easier because now all we need to do is map the arguments. Cool. Whoops, typo. That should be expand quote. All right, so let's see here. You know what we don't need anymore is this symbol literal nonsense. Oh, we don't need any of this anymore. Oh, so nice to delete code. Okay, so I think everything else should just work. All right, so here's what I'm gonna do. Just kind of in line here as we've been doing. I'm just going to try to compile some crap. So let's grab our read function. Where is it? It's blisp/reader/read. All right, so our form that we want to compile is going to be our usual suspect here. Oh, you know what? we have some other work to do before this will work. Okay, so let's just start here and let's log this out. And I already think I know a bug. Oops, you know what? We're just gonna run node, and somewhere in here we have a saved thing. Cool. Let's run it so that we pause on that error. Oh, you know what? Look at this. There's already one bug. I forgot to close my parenthesis. It'll be great when we have IDE support, and that's not a problem anymore. That's a weird place to break. Let's see here. Let's look at args. Wait a second. Why do we have a symbol? Oh, you know what? Our read table has some jank in it. Okay, so first of all, this dot needs to be a little smarter. All right, so this is going to get a stream, a char, and a value. So what we're going to do is we're going to okay, so this is stream next value. All right, so this is just filling this out. So basically for dot, well, we only want to parse a number if the next character is a number. So basically what we'll do is say if next is, how did we do this? All right, so if 0 is less than or equal to next, and next is less than or equal to 9, then we're going to read number. Otherwise, we'll do ReadSymbol with stream next and char. And then what we need to do is import ReadSymbol. And we need to jump into these functions and make them ready to, oh, come on, command click. Nope, it's not going to command click for me. Do I need to stop this? Okay. Okay, thanks VS Code. So we just need to assign our initial value to the value that's passed in, or an empty string. And we'll do the same in read string. And ReadSymbol. I think that's all we need to do for that. And let's see. So someplace, whoops. Someplace we have a read table that you know what? I think it's ReadSymbol. Shoot. Someplace we are we have a reader function for this guy. Oh, look at that. I've done this before. Wait a second. Okay. where were we? So I think we have some kind of problem here. I don't know where the symbol's coming from. I really don't want a breakpoint there. Okay, just let's just run and see what happens. So here we are. Read. Okay, this is not really helping me too much. Let's see, we're in read. Do we have access to read table right now? Okay, let's just see here. Okay. Let's just peek. Let's see, what do we have here? Args, we have an object and we have a symbol. So somehow, where are we getting the symbol from? Is there a ReadSymbol table? There it is. Okay, found it. And this should be t.identifier. Yeah. Okay. So let's try this again. Yep, that would indeed help if I actually imported that, huh? All right, so basically I just didn't import identifier from Babel. Alrighty. Okay, one more time. Okay. Alrighty, what's next? Okay, so looks like we read our form, all right. So now we want to generate it. The thing is that we need a macro, so we need to then set up our env. All right, so env equals, let's see, how are we resolving this? I can't remember. All right, so we're resolving it by string. Okay, cool. Whoops. Yeah. Oops, that's a little big. Okay. Okay, so all we need to do is put a little dot in here and give it a function. So this is going to take our call form and an environment. So what do we want to do? Basically, all we want to do is member expression and I'm just gonna call expand. It's not obvious to me what we've got here. All right, so here's where I want to start abstracting some of this stuff. So basically, this is callee and this is arguments. So I'm going to write two functions in line here. We're going to split these out into modules for later, but for now, let's just do this. All right, so first form. And so basically, this is going to be super exhausting, but maybe it won't be too bad. So we're just going to fill in the pieces we need to say hello world again. All right, so first for call expression. Actually, you know what? I'm gonna make function nth form and end. So this will be 0 based. So form dot type, and so what we want is case call expression. All right, so and what we can do here is just say return n is equal to 0, then form dot callee. Otherwise, we're going to return form dot arguments n -1. Okay, so basically that means that this is just gonna make it look like an S expression. And in first, we can just call return nth form 0. All right, so rest is going to be a little more complicated. We'll have to do some more work, but for now, what we can do is say switch form.type, and in the case of a call expression, we can just return. So this is the thing I was just hypothesizing about. So if you call rest, the idea is that you should get all of the elements except for the first one. And I don't know, should this return an array or should it try to return the same type? I'm going to just go with returning an array for now. So it makes it a little easier here. All we have to do is return form.arguments. I guess that'll make it look a little weird. Anyway, I'm also going to make a second function just for convenience right now. Form 1. Cool. So what are we doing here? Member expression object. All we have to do is we're going to expand. Oh, this is second. Screw it. Let's get third. All right. All right, so we'll expand that with our env, and then we'll expand our third with the env. Cool, so now let's go ahead and expand. All right, expanded equals expand form and our env, and then we'll log that out. Okay, let's just run this in the terminal, see what we get. Okay, this should have been expanded to a member expression, so we didn't resolve this. Oh, you know what? I remember. I think I had this as an array in this branch. I'm gonna try that again. Nope. Okay. Well, let's do this. We're just going to. Okay. Oh, you know what? Let's see. Yeah, that's 0, 1, and 2. Okay. Okay. Let's just inspect what's going on here. All right, so callee. So our callee is a call expression. So we'll jump in here. Let's just syntax. So we have a call expression. Wait, this is dot dot. Hold on here. What did we do? I think I broke my read table. Where are we? Read table. Dot. See, we peaked jar. Okay. But okay, so this is what we want, but what we need to do is read it. All right, so basically we didn't advance the input stream, and that's obviously just not what you want. Oh, that's probably not going to do the right thing. Oh, look at that. It is. Great. All right, so I'm going to run, and so now syntax.callee should get resolved to dot. So let's just check first. It's an identifier. It's not quote. Do we resolve it? No. Nope, nope, nope. That's interesting. What is symbol? What is env? Look at that. Wait. Oh, I put my array in the wrong spot. Whoops. This is an array of functions. It's not an array of, it's not a function returning an array. Somehow, all right, we're gonna have to refactor all of this crap, I'm pretty sure. Okay, so we're gonna run, and what we're looking for here is that we're going to expand this guy. Great, so we have a function, and our return value should be a member expression. Great, okay. Cool. Yeah, now all we need to do is generate it. Probably don't have that. All right, I'm just gonna grab that from Babel real fast. And we'll generate our expanded form and log that out. Let's just run this in terminal. I'm very confident that we don't need a breakpoint. Look at that. We've got our console.log foo. And now let's evaluate it. Dot code. And we're back to hello world. And I think things are starting to make sense, huh? So the cool thing here is we can also throw something in here for arrays. So, in the case where we call rest and we get an array, we can continue using our basically syntax inspectors. Awesome. I'm pretty excited. I think that this solves pretty much all of the problems that I was actually worried about. Yeah. Okay, cool. So I think that this is a good strategy. So I'm going to just go ahead and check out Okay, back to Babel AST. Start prototyping next AST format. Okay, I'm gonna push this up. And so I'm going to take a break for a little while, and I think I will be back, and we'll see if we can't start fleshing this out. So, as always, thanks for watching, and until then.